Hello friends, welcome to this new video on Unified Performance-Based Design for RC frame buildings. We shall apply it in SAP 2000 software and carry out a real design for a building. The problem is like this: to design a 3-story RC frame building with a given plan, the target performance level is IO and the target interstory drift is 1.5%. The building is in Zone 5 of India. The foundation rests on medium type soil. Now for Zone 5 of India, the zone factor is 0.36. This is the seismicity level at that zone. We take concrete grade as M20, that is the FCK. The characteristic strength is 20 megapascal. And Fe500 reverse steel, which has the yield strength as 500 megapascal. The plan of the building is shown here. 3-story building, so plan is regular rectangular. There are 6 columns in one row. There are 3 rows here, so 18 columns. And the size of the columns are given here along with the steel provided. This steel provided you can ignore because we are going to design it and find out the new steel, new design. The section sizes of the columns are given from some empirical initial design, and rest of the things we have to. So Fy is 500 megapascal. The plastic rotation for beam for IO performance level is 0.00625 radian. The strain in reverse steel is 500 by 2 into 10 to the power 5, which is 0.0025. Theta is 1.5%, meaning 0.015 radian. For a building, we have to first find the equivalent single degree of system properties. And for the given building, we have to find the equivalent single degree of freedom of system properties. So there are 2 directions, short and long. Let us find out this property along the short direction first. We have the critical story, which is the ground story, because its height is largest, 5.1 meter. Then theta d is given and delta c is given by this formula, theta d into AC. AC is the critical story height. Now we can find the phi I from this formula. Phi I equal hi by h when number of stories is less than 4. So we put the floors, then we put the heights, then masses. Masses is collected from the joint masses of the system, and then can calculate the mode shape coefficients from this formula. These are the values. Then find out the displacements of the stories given by this formula, phi I delta c by phi c. Delta c is here, and phi c is the value of the phi at the critical story, that is this value. Then simply it is finding the mass into delta I product, then mass into delta I square product, mass into delta I into HA product, and find the summation of all these 3. Then the equivalent single degree of freedom system properties are given here. Delta D given by this mi delta I square, so this one divided by mi delta I by this, so I get this. Design displacement 0.173 meter. Equivalent mass summation mi delta I by delta D. So mi delta I summation is here, divided by delta D is this, you get this much kg, because initially these values were put in kg. Effective height is given by mi delta hi divided by summation mi delta I. So this comes 8.815 meter. Epsilon y we have seen already. Then theta pb is this much, theta d is this much given. For this we have to design the system. Now the depth of the beam will be obtained from this formula, 0.5 epsilon y lb divided by theta d minus theta pb. Theta d is design drift, theta pb is the plastic rotation in the beam corresponding to the performance level desired. Now our desired level was IO performance level. So these are the beam lengths along the short direction. 2 spans are there along short direction, 2 beam lengths, and the HB comes like this. Now we've taken a slightly lesser value than the computed value, because It is a real building, and thinking about the shuttering, which is given by planks of 300 millimeter or 1 foot wide. So it was taken as 600 millimeter, and depth is half of that, 300 millimeter. So beam size decided. Now we find the yield rotation of the frames given by 0.5 epsilon YLB by HB. There are two beams, so we find out the beam lengths, then the HB is same for both the beams, 0.6, and find out delta YF. Then we take the average of these two. This becomes the design yield rotation of the frame. Now the yield displacement of the frame is given by theta YF into HE, effective height. So we get this as 0, this much meter. Now the ductility is given by maximum displacement, which is design displacement, divided by yield displacement. We get 2.03. And the corresponding equivalent damping for this ductility is given by this formula for RC frame building. So it comes 16.4%. Now we draw the displacement spectra corresponding to Indian design spectrum at 0.36G level. So at various damping, these are done 5%, 10%, 15%, 20%, and we also draw at 16.4%, which is just below the 15% line. So this is shown by this dotted red line. So this is our design displacement spectrum. From here, this blue dotted line is the line corresponding to the design displacement 0.173 meter. So where they are intersecting, this red line and blue line is the value of the effective time period. So it comes out as 2.1 second. So if it is 2.1 second, then you can apply this formula, effective stiffness 4 pi square me by T E square. So this comes out this much Newton per meter. Base shear K into delta D. So if you multiply this with the delta D, I get 466 kilonewton. Now this base shear is to be distributed over the floors. When number of stories is less than 10, the distribution formula is this: base shear BB mi delta I divided by summation mi delta I. So we have taken the floors, heights, mass, delta I computed earlier, and find this product and distribute as per this formula. Then the forces, design forces from earthquake as per UPBD method is coming out like this: first floor 106, second floor 178.9 kilonewton, and roof level 181.1 kilonewton. Now let us see the long directional computation for ESDOF system properties. The computation flow is same. Now let us take the ESDOF system properties along the long direction. Initially this is same as earlier case because the masses are not changing, shape profile is not changing. So after the calculation of delta D, ME and HE, it is same as earlier. Now the length of the beams along the two directions are different. Depth of beam we shall be taking same as earlier, that we should not change. So now calculation of theta YF by this formula is carried out for each beam. Along the long direction there are 5 beams, 3.8, 3.65, 2.75, 3.2 and 2.66 meter long. Depth of the beam is 0.6 constant. We find out through this formula the yield rotation of the frame for each beam and take the average. Now your yield displacement is theta YF into HE. So this multiplication gives you 0.059 meter. Ductility is delta D by delta Y, comes out as 2.93. The damping corresponding to this ductility comes out through this formula as 20.9%. Now we draw the displacement spectra corresponding to 0.36G for Indian code, and draw also for 5%, 10%, 20%, etc. and also this exact value 20.9% corresponding to our present case. This is the design displacement line and this red line is the displacement spectra corresponding to this 20.9% damping. So they are cutting at this point where the time period is 2.28 second. So t equal to 2.28 second. K equal to 4 pi square me by t square gives this much Newton per meter, and the base shear K into delta D gives you 395 kilonewton. So distribute this base shear by this similar procedure as we done earlier, proportional to the mass and displacement delta I. So the values are coming like this: 89.19 kilonewton, 151.7 kilonewton, and 153.5 kilonewton. So these design forces are to be put on some representative central point in each floor of the building. This is one way. The other way is you can distribute it equally to all the joints in a particular floor. The staircase cover. This also will contain the water tank and filters if any. So this is the building. The load givens are like this: load patterns, self weight, which is the multiplier as 1, then live load, dead load, roof line load, stair dead load, etc., and other infill. These F short and F long are the quake loads arising out of the UPBD method. Now let us see the load combinations. The load combinations in UPBD method or DDBD method are very simple: dead load plus live load, then dead load plus live load plus or minus F short. There is the quake load along the short direction. Similarly, dead load plus live load plus or minus quake load in the long direction. This much only. Let us see the load cases for understanding. This gravity X is the initial. Gravity X is the initial load to be applied for making the time strain lines. So this has a directional meaning, so that's why gravity X name is given. Here all the selection is load pattern, and all the loads whatever we have given are given with the appropriate scale factor. For live load is 0.25, and for stair live load, which is slightly higher, is 0.5. P delta F is considered static non-linear, and you have to give the direction here. U1 means x direction, and that's why it is name was given as gravity X. And you have to select a joint at the roof level. So we have taken a representative point at the central point, 47 level. Other modifiers are available here. It is only final state to be saved, and these are default values. Now after gravity X, you can carry out say GM1X. That is, GM1 means the ground motion number 1, GM2 ground motion number 2. These are all spectrum compatible ground motion, compatible to Indian code at 0.36 G level. So if you see the G1X, how it works, let us see. It starts with gravity X in the beginning, continue from the end of gravity X, and it is non-linear, it is time history, it is we are applying direct integration process. P delta is considered, and direction is U1 because we are telling it is gravity X. Acceleration is selected, direction is selected, and ground motion is selected. And scale is 0.36 into G. G is 9.81, so this comes out as this. So this is the scale. Other options are available here. I have given 5% damping, and it is Hilbert-Hughes-Taylor method of direct integration. These are default values, I have not changed. So this way gravity Y is given, and GM1 or GM2 etc. all these directional time history analysis load cases are produced. I have taken only 2 ground motions. In fact, you have to make at least 11 ground motions as per FEMA 356 and ASC SEI document to take an average result. For the sake of brevity, we have taken only 2 ground motions. Now perhaps we can go to after time history application, what were the results? You can see here. Let us see, say, under gravity GM1 under y direction, and at which instant you want to see the condition of the damage. Let us see, the last one is 42nd. So if we apply it, it will show you the final state of the building at that instant of time. You see here all the plastic hinges are shown in the pink color. So this is IO level. It is indicating the building is displaying IO condition. Similarly, under other load cases also, it showed only IO condition. Let me show you the time history we have taken. One is GM1. It is with background earthquake El Centro. You require a background earthquake for generating SCGM El Centro, and GM2 ground motion number 2 is like this. It's a background earthquake, if I remember, was Kokeli earthquake. So you require 11. I have taken only 2 here. Now all the load cases are set, and we have run the time history, and the results are obtained. Now the results I'll show you in the Excel sheet. I want to draw the interstory drift diagram. So this corresponds to the roof level under GM1, then GM1X, GM1Y, GM2X, GM2Y. These 4 conditions are available. So this is the roof level displacement history. This is 2nd floor, and next one is 3rd floor. I think it is not correct. Yeah. This is roof level, floor 3, then this 2nd floor, this 1st floor. So how to get the drift, interstory drift between 3 and 2? 100, because we want in percentage, then absolute difference between this 3 and 2 divided by height of story, 3.2 meter. So this way you get all the story drifts. This line is showing you story drift between the floor 3 and 2. And you get the maximum value out of this through Excel. Maximum value is 0.12%. Similarly, between 2 and 1 we generated, and it is 0.24%, and 1 and 0 0.47%. 1 and 0 means ground level. So if you draw it, you get this diagram. The diagram can be drawn in 2 ways. One is just showing the points here, 1 point, 2nd point, 3rd point, and join them. This is one way. Another way is showing the stepped distribution. This seems to be more appropriate, because in the 1st floor, 1st story, the drift is this much, which remains constant in that story. 2nd story, which height ranges from here to here, its drift is this much constant. So this representative seems to be better. Now your target displacement also you show here. Target displacement is here 1.5%. So actual drift is much lower than the target, so it is certainly a safe design, but maybe slightly uneconomical, because we did not do much calculation for the columns. So columns are perhaps stiffer, and it gave lesser drift. Let us see another along the y direction under GM1, and the values are like this. We have drawn it again. Here also this is within the bounds, so drift is, you can say, drift is satisfied. Let us see the other one. Here also drift is satisfied. GM2 along the x direction, drift is satisfied. Under GM2 along y direction, I have not drawn it because drift is still smaller. This much only drift. So the building we have designed is satisfying the IO performance level, and it is also satisfying the target drift 1.5%. Yeah, we are at the end of this presentation in this video. So in this video we have learned how to apply the UPBD method for designing a RC frame building. We have to first calculate the equivalent single degree of freedom system properties, Then from the length of the beam we calculate the depth of the beam. We take the width of the beam varying from say 1/3 to half of the depth empirically, and that gives the beam size. So beam size you need not really calculate. This will satisfy your drift as well as your performance level. Our target performance level was IO, and our target drift was 1.5%, which have been satisfied by the building. Thank you for coming up to here. Please share and like the video, subscribe the channel, and put your queries and comments in the comment box. I shall be glad to answer those. Thank you, and we'll meet again soon.